Okay, hi everybody and welcome to this session. My name's Steve Sanderson and I'm one of the developer architect type people on the .NET team. And I'm here to talk to you today about some of the things that we are adding into .NET to make it easier and more productive for you adding AI features to your application. So before we get into some of the code related to that, let's just start by stepping back and thinking about why. Why should we add some AI related stuff into .NET? What business is it of the .NET team to do that? So let's think a bit about what it is that we're trying to produce for you as a product in .NET. So we're focused on a few main areas as the .NET team. One of them is the things that only we can do. So as the platform owners, it's up to us to make sure that we keep moving the C# language forwards, that we keep things like the package management ecosystem in the right way. We do whatever kind of IDE fundamentals are needed. Obviously, we have to do it because no one else can. But apart from that, we're also quite heavily focused on making you more productive when you build your applications. So producing reusable building blocks that take away some of the workload that you would otherwise have. And one of the areas within that that's quite interesting is a thing that we call exchange types. So we try to create a set of types to represent common application scenarios that are highly reusable, that are really well thought through, and that will work across all the different packages and applications. Now, if you don't know what I mean by that, let's think about some examples, because if you've been around .NET for a little while, you will actually know some of this already. So let's think about, for example, logging or caching or dependency injection. Well, we've got these packages, which you may well have already used, that are inside the Microsoft Extensions namespace, and they provide reusable implementations of many of these things, as well as the core abstractions that are the exchange types across packages. So you might think, well, given how important AI is within the software industry and how it's likely to just get more important from here, should we do the same thing for AI? Should we continue the same naming pattern and have some package called Microsoft.Extensions.AI that contains the reusable pieces and common APIs for working with AI services? Now, as you can probably guess, we think the answer to that is yes, and that is what this talk is going to be about today. So that's what I'm going to be showing you is this package that we've actually just released already in preview form called Microsoft.Extensions.AI, which gives you some common building blocks for AI features in your application. So I'm going to show you a whole bunch of different scenarios now in code and give you a sense of how these APIs work and what kind of things you can build with them. And we're going to start with embeddings. Now, you might already know what embeddings are, but just in case you don't, embeddings are a way of taking some input, which could be text or an image or something else, and converting it into an array of numbers, a vector in mathematical terms. And that represents the concepts within the input. So it doesn't represent the characters or the pixels. It represents the actual semantic concepts. And you can use that for features like semantic search, and classification and many other things. But let's start with seeing how you can do that with these new APIs. So I'm going to do this in a console application just because I know everyone's building different types of apps and I want to keep things as simple as possible. So we're going to build a console application using Microsoft Extensions.AI. And the first API that I want to use is this thing called Embedding generator. And this is going to take a string as an input in this particular case, and it's going to return to me an embedding or a vector of floats that represents the meaning of whatever I pass in. Okay, now I can wire this up to different backend implementations. In this case, I'm going to use something called Ollama. Ollama is a way of running AI models locally on your workstation. I'll swap this out for other things in a minute, but we'll start with that. Okay, so the first thing I want to do is generate an embedding. So I'm going to start with this very simple factual statement that everybody would agree with, that cats are better than dogs, and I want to generate an embedding from that. And I'm going to show you what this looks like when I do it. It's going to give me back a vector of a particular length, and I'm going to display all the values that are in it. So let's run that. And you'll see that because of this particular AI model that I'm using, that happens to return a vector of length 384. And these are all the values inside that vector. Now, obviously, these numbers don't mean anything to us as humans. But within the context of this particular embedding model, they represent the actual meaning of this phrase. So not the characters in it, but the meaning of the concepts in it. And we can use that to implement many features, including semantic search. So I'll give you an example of how we could do our own semantic search feature just using that. So imagine the scenario is that you want to create some sort of like help system for your application or for a set of documents that you've got, and you want people to be able to search through them semantically. So here I've got some test data, which is this long list of different document titles. They're all stuff to do with HR concepts, like for a business in some way. Okay, and I've got 100 or so things in that list. And what I'm doing is telling my embedding generator that I want it to generate the embeddings for all things in there. And I'm using this API called generate and zip, which combines all the inputs with the outputs to produce a list of pairs. So if I run that with the debugger, we should be able to see that that generates embeddings for all the entries in there, and we will be able to get the corresponding values. So here we've got our list, and each entry in this list is one of the titles, and then we've got the corresponding embedding. All right, so now let's do a simple semantic search feature. I'm going to do this as a little REPL, a read eval print loop, where I'm going to loop around. I'm going to keep reading stuff from the console. And then whatever the user types in, I want to generate the embedding of that. So we get a vector. And now I need to search through all the candidates to find the most similar embeddings. So what does it mean for two embedding vectors to be similar? Well, you can define similarity in different ways, but the most common way that's used is something called cosine similarity. And that's what I'm going to do right now. So I'm going to consider all the candidates, and for each one, I'm going to compute the cosine similarity. And what that is mathematically is it's the cosine of the angle between the two vectors. So you imagine these embeddings are directions in some sort of embedding space, some high dimensional space, and we calculate the angle between them. And the closer that angle is to 0, the more they're pointing in the same direction, the more similar they are. And if they were pointing in exactly the same direction, the angle between them would be 0, and you might remember the cosine of 0 is 1, and that's the highest value that cosine can produce. So this gives us a number between -1 and +1, representing similarity. And then I will simply display the closest 3 values. So hopefully that is not too overwhelming. It's not very much code, and it should give us a very nice semantic search feature. So if I go in here and I now search for something like exercise, then it will return document titles that are related to the concept of exercise, even though they don't involve the actual word exercise. Or I could search for where to park, and it's going to give me stuff to do with parking, or some other kind of typical workplace task that you've got, something like pranking coworker. Then it's going to give me a nice helpful menu of suggestions of ways you can do that. Although to be honest, I don't even know what kind of prank it has in mind with this one. I probably don't want to know, so we'll just move on beyond that. Okay, so that is a very simple introduction to how you can use iEmbedding generator to generate some embeddings and then implement a little semantic search feature. And we'll do that in a more advanced way with a vector database later on in this talk. But before we get to that, let's move on now to the real star of the show when it comes to AI, which is language models. This is a very general purpose tool that you can use to build all kinds of application functionality. So you might be thinking, first of all, it's a language model. This is like, for building chat-based systems, and you can use it for chat, but it's also for many other things as well. You can automate all kinds of business processes like classification, summarization, cleaning data, detecting anomalies, all kinds of things. And I'll show you an example of that in a little bit. But let's get started with the basics of this and what the new APIs actually look like. So I'm going to switch over to a different sample project now. And you can see in this case, I'm trying to make it look a little bit more realistic. I'm setting up a DI system, and I'm going to register an IAT client in there. Okay. Now, just like before, I am going to use Ollama to get started. I'm going to swap that over for OpenAI in a minute, just to show you that we can switch for different things. But let's start with that. And then I'm going to register my iChat client inside dependency injection like this. And we'll come back to why the code looks like that in a little bit. But in summary, iChat client is the new standard representation for a language model that you can call in .NET. Okay, so given that, how do I do a simple call into it? Well, it's pretty straightforward. I can just call this complete async method and pass in some input, and it's going to give me the response as a string. So if I run that now, then what we're going to get back is some response to that. Now, I'm actually using Ollama here, and so it takes a moment to load because it's actually loading a large language model on my laptop, but it's done it. It's returned a sensible response. And if I run that one more time, then it will complete a lot faster this time because, the language model is already loaded. OK, now that is just getting back all of the response at once, which is fine. But if you're going to get back a long response, you might want to stream it back so you don't have to wait for it all to be generated. We've got another API for that called complete streaming async. So in this case, I'm telling it to respond with 1,000 words. I don't want to wait for it to generate them all. I want to see them streaming in. So because I've got that await for each loop, it's going to display all the output as it gets generated by Ollama there. And of course, I can swap to different backend implementations of this. With Ollama, I can use different language models. For example, I could use this small model called Phi3 Mini from Microsoft. And if I run that, that will just behave in the same kind of way. It's actually a little bit faster and less intensive on my hardware there. But the real advantage of having an abstraction like IAT Client is that you can swap out entirely different backend implementations. So as an example of that, I'm going to bring in Azure OpenAI. And we've got implementations of IAT Client for all kinds of different language model services. And I'll show you a list of those later on towards the end of the talk. But let's have a go at using Azure OpenAI right now. I don't have to make any other changes to my code. And it's just going to now start streaming some response from GPT-4o there. Of course, I do have to pass in my API keys, which I'm getting out of configuration in this case. All right, so that's fine. Now, you might be thinking, OK, this is all very well. I get what you're saying here. But there is a bit of a drawback to using an interface like IAT Client, which is this is sort of the lowest common denominator of all the APIs that are supported by different backend implementations. Like, what if you want to use some APIs that are specific to the actual provider that you're using? Like, what if I want to use something specific to OpenAI or Azure OpenAI? Well, that's something we've designed for as well, to make sure that you can always get out from the abstraction anytime you need to do so. So as an example of that, I'm just going to go back to the slightly simpler version of this. And I'll show you that on this response object that comes back, we can access provider-specific data. So we've got a property on there called raw representation, and you can test for different types of things it can be. In this case, I'll check to say, is that an OpenAI completion? If it is, then I can access some OpenAI specific data in a strongly typed way. So OpenAI gives us this system fingerprint, which other backend services might not do. But in this case, I am using OpenAI, so you can see I can access the OpenAI specific data. OK, so that's all very well. That's some very simple usage of a chat client. What about if we want to make this do something a little bit more interesting? So let's take this forwards now to working with functions. Functions are the way that an AI system can actually do something useful within your application instead of just responding based on whatever knowledge is baked into the language model. So a function allows it to call back into your code to get more data or to make something happen. Right, now there's many different ways that we can use functions. The first thing I'm going to show you is how we could use this to build a chat type system. Okay, it's a very common thing that people want to do, and I just want to show you that it's not difficult at all to do something like that. So I want this to be stateful, so I'm going to keep track of all the messages that are going on in my thread of conversation. And I'm going to make this be a general chatbot that can answer any question, but it's got a secret agenda, which is that it's trying to sell these Foot Monster brand socks to the user. Okay, so let's have a go at doing that. Once again, because this is a console app, I'm just going to do a little loop where I'm going to read some input from the console. I'm going to add that to the list of messages, and then I am going to get the language model to give me a response. Based on that, I'll add that to the list of messages, and then I'll display it in the UI. Okay, so let's run that. I can now hopefully have a conversation with this chatbot where I say something like, what is 1 + 1? And it will give me a response to that, 1 + 1 = 2. And speaking of pairs, have you thought about buying some socks? So, OK, that's great. It's clearly working. But what happens if I try to get it to give me some information like this? How much per pair? Like I want to ask it for the price of a pair of socks. Now, remember, in this system prompt here, I didn't give it any information about pricing. So what do we think it's going to say if I ask it that question? Will it make up a price? Will it say it doesn't know? Well, let's find out. In this case, it just says the price can vary. So different models will behave in different ways. Smaller models will probably just hallucinate something. GPT-4o is quite resistant to hallucinating, so it will just claim that it doesn't know, which is true, it doesn't know. All right, but I want it to actually give me real pricing information. And this is where I can use functions. All right, so I'm going to define a function or a C# method called getPrice. Okay, and I'm going to give it some metadata, like a description of what role this particular method plays, the fact that it takes a parameter called count, and it computes the price like that. Now, I want to make that available to my iChat client. And the way I can do that is by setting up a chat options and giving it some tools. So the tool in this case is this thing called getPrice tool. And what I'm doing is I'm taking my C# method or delegate and I'm converting it into an AI function. And what an AI function is it's just metadata. So it's a description of the name of the function, any description I've added, the list of parameters, the return type, all that kind of stuff. And it makes that available to the AI system. So it can call it if it wants to. Okay, now I have to pass that chat options in here for that to work. So now it's got access to this getPrice function. So let's try running that again. And I'll say, hey, and then it'll try to sell me some socks. And I'll say, how much for 1 million pairs? And hopefully it will then call my C# function and it will get actual price information. As you can see, it does there. All right. Now let's say I want to take it forwards another step. Okay, buy them. What's it going to do if I tell it to buy them? It will say, sorry, I don't really have the ability to do that, because I haven't given it the ability to. So let me take this to the next level up by making it into something stateful now. So instead of just being a pure static function, I'm going to turn this into an entire class so we can keep track of information. So I'm going to define this class called cart, which keeps track of the number of pairs of socks. I'm going to have this function or method add socks to cart, which in this case just logs stuff to the console, but you can imagine it doing something more. And then I've also got the getPrice down there. All right, now I want to make all of that available. So I'm going to add both of those tools into my chat options now. And I'm also going to slightly improve the prompt to give it a bit of a sales script so it knows what to do. I'm going to say, first get them to agree to buy socks, then find out how many pairs they want, and then add them to the cart. Okay, so let's see if that actually works. So let's say, hey, and it says, are you interested in socks? And I'll say, sure. How many do you want? Let's say I want 250,000 pairs of socks. Now it will add those to my cart, as you can see. And of course, this is all stateful, so I can say, oh, actually, I need one more pair. And it will add the one more pair into my cart, and you can see it's gone up in the way that it should. Okay, so those are some examples of how we can use functions within our system. And the real point that you need to take away from this is that it's a fairly non-trivial thing to define how functions are specified and how they get called and things like that. And we're providing this standard programming model that will work whichever kind of back-end AI service you are using. Okay, so that's great. Now let's move forwards to talk about pipelines and middleware. So why are we doing this and what are we getting at here? So one of our key design goals when we're building APIs like this is to make it as flexible as possible for you, because this is only successful if it works in a really wide variety of applications and across a wide range of different NuGet packages and different scenarios. So a very powerful pattern that we can bring to bear on this is something called middleware pipelines. If you're an ASP.NET developer, you're probably quite familiar with this already, but we also use it in other cases like HTTP client and other things like that. So by setting up a pipeline of functionality, we make it possible to mix in different behaviors in a way that composes together and allows you to extend it. And I've already been using an entry in the pipeline already. I've got this call here to use function invocation, and that's the thing that actually turns on the ability to call the functions that you've supplied. But there's many other bits of middleware as well, some of which are built in and you can make custom ones. For example, we've got use logging, and we've got use open telemetry, and we've got use distributed cache. And these are all built-in ones that you can just use out of the box, but you can make your own ones. I'll just show you how use logging works for a start. So if I run this again now with that in the pipeline, and I'll say how much for 88 pairs of socks, then because I've got use logging in the pipeline, you'll see it dumps all this extra stuff into console. And it's quite hard to read, I appreciate. But if we look very closely, you might notice that here we can see it's logging that it's making a call into get price, and it's passing a count of 88 into it. And then the response goes back to that, and that's this response here. And you can see the result, so it's very hard to read, but it's 140712. That's the result that comes back. And you can see that that's what then ends up in the output to the user. All right, so that's some built-in middleware. But what if you want to implement your own? Well, it's pretty straightforward to do, and I'll give you an example of it over here. So I'm going to define a new middleware step called use language. And I've defined it as an extension method on Chat Client Builder, which means that I can call it as part of a pipeline. And I'm saying that you have to pass in whichever language you want it to be. All right, so over here, I could now come to this line here and say use language, and then pass in the name of some language that I want to use, let's say Swedish in this case. Okay, so that's now going to add a new instance of use language chat client into my pipeline. All right, now this is a bit technical, but the pipeline is a series of iChat client instances, and each entry in that pipeline can just resolve any question that comes to it directly, or it can pass on to the next stage in the pipeline. And so normally, each call passes through each stage in the pipeline all the way to the end where it gets sent over a network to some backend service. But at each stage in the process, you can override what's going on. So in this case, I want to override what happens when a complete async call is going through this. And the way I'm going to do it in this case is using a technique called prompt augmentation. It's not the only thing you can do, but it is a good thing that you can do. So what I'm doing in this case is I'm defining an extra chat message that says always reply in the language and then whatever language it is that's been passed in. Now, you don't have to really hard code it. You could vary it dynamically based on the thread culture or whatever else you wanted. But I'm just setting whatever language gets passed in, and I'm adding that into the list of messages. And then I'm going to simply pass through to the rest of the pipeline. Now I have to make my method async for this to work, but I'll pass through and it will call the rest of the pipeline steps with this extra prompt in it. And then finally, just to be a good person, I'm going to clean up by removing my prompt augmentation from the message history so we don't leave all these extra bits of message behind us. All right, so let's see if that works. If I run this again now, and I'll make a question to it in English, I'll say, hello there, in English, and it responds by saying some stuff in Swedish to me, and it's going to try and sell me some foot monster strumpor in this case, and I'll say, buy 500 pairs, and we should expect that all the other stuff, like function invocation, will still work, because all this stuff composes together. Now, that's an example of doing prompt augmentation, but it's not the only type of thing you can do. You can also use middleware to control things, to do it like control flow things. For example, we can block certain requests from coming in, we can resolve them from cache, we can do rate limiting, we can do all kinds of things. We can branch to different backend implementations. As an example, I've got another thing that I've just implemented here called use rate limit. And that's going to use .NET's built-in fixed window rate limiter API so that when somebody calls complete async, it's going to try to get a lease on that rate limit. And if it can't, it's going to refuse to process it. It'll just say skipping. But if it can, it will call through to the rest of the pipeline. All right, so given that, I should be able to come here and say use rate limit, let's say time span from seconds 5. And now I'll go in here and I'll send some message. And if I send messages too fast, you see I get this skipping due to rate limit. And after 5 seconds, then I don't hit the rate limit anymore. All right, so that's a very general purpose, powerful facility that you can use to mix in functionality no matter which backend implementation of your AI service you're using. All right, so now the last of these chat-related things I'm going to show you is something called retrieval augmented generation. This is something that people very commonly want to implement, which is the ability to have what sometimes they call enterprise Q&A or some sort of chatbot that is connected to your own data and is able to give responses specific to your business scenarios. Okay, and the reason I'm showing it to you right now is really just to show you that it's not very difficult. You've already seen all the pieces that are needed. We just have to put them together and it should work pretty straightforwardly. So again, I'm going to switch over to another example. And I know it looks like there's a lot of code and you can't read it all, but this is all just DI config. So you can ignore that for now. And I'm getting an IAT client out of dependency injection. And what I'm going to do is create a little chatbot that can produce reports of things that people are posting on the .NET runtime repo. So let's say I want to do some general sort of sentiment analysis. I want to see what people think about different parts about .NET. And I want to create an AI system that can search over the .NET runtime repo issue tracker and tell me what people are saying in general. Okay, so what I'm going to do is, just like before, I'm going to make a little chatbot that keeps track of messages. Again, I'm doing it as a console application. In reality, you're probably going to build a web UI or you're going to build a native UI in some way, but I'm trying to make this inclusive to everyone, so we're just doing a console application. Right, so my system prompt is saying, search for issues relating to their question, summarize the general vibe about it, and then give responses with citations of which GitHub issue you're saying is the basis for whatever claim you're making. All right, so just like before, I'm going to have a loop that loops around, reads some input from the user and adds that to a list of messages. And then I'm going to tell my AI system to complete. This time I'm going to do it in a streaming way, and we'll write all that stuff out. Now, I haven't yet wired this up to my actual real business data, so it has no information to base its answers on at all right now. If I run it, let's just see what it says. I'll say, what do people say about Perth? Okay, and remember, it has no information at all to base its answer on. And it's going to just give me a bunch of stuff that GPT-4o thinks that software developers think about Perth. Okay, and it's referencing all kinds of stuff that's got nothing to do with .NET at all. It's making up all these different issue references. For all I know, these might be real issues on some repo, but it's got nothing to do with .NET. It has no basis for saying any of this stuff. So what I want to do is now connect it to my real .NET runtime data. So I've added a class here called semantic search, and that's going to combine the two things that we know about, embedding generation, and it's going to be able to do it's actually just going to do a search through a vector database to get results relating to a particular keyword. So I'm defining this method here called search for issues, which will take a search phrase. I'm going to generate the embedding using the same technique that we did before, and I'm going to use a vector database called Quadrant in this case to search for issues relating to that, and then we'll return that back to the language model. Now, you might remember from before, in order to actually make that available, I need to define some chat options that contain a reference to that. So here I'm creating a search tool that has got the ability to call this search for issues. Okay, and that hopefully should be enough. I've got a breakpoint on there, so I'm going to run this and see what we get. So I'm going to say, do people like C#? And I'll run that. And then hopefully that is now going to hit my breakpoint here, and it does. And you can see it's choosing to do a search for like C#. Okay, I'll run that again. It's actually chosen to do a second search. It can do as many searches as it wants. It's also searching for dislike C#, and it's doing a third search now for C# pros, probably C# cons. And eventually it's decided it's got enough information, and it produces a report based on all the different issues that it's found on the .NET runtime repo, and it's given me citations of the different issues that it thinks are the basis for that. Okay, so hopefully you'll agree that that is not overwhelmingly difficult to do. Right, now let's move on to the final thing that I'm going to show you now, which is going to be a non-chat scenario, because I personally think that in order to produce the largest amount of business value, you probably don't actually want to start with chat. You want to look at ways that you can automate business processes. So let's have a go at doing that. And just to make it interesting, I'm not even going to use text this time. We're going to be working with image data, just to show you that we can. Right, so let's move back to this chat scenario from before, even though we're not going to do chat now. And I'm going to just clear out all the code in there, and I will reset back to a good state. So pretty straightforward starting point. We've got a reference to a chat client, which is GPT-4o Mini. I've got a pipeline that just does function invocation and nothing else, and that's it. All right, so what I want to do is show you firstly that we can feed images into this system. So I've got this directory over here, of a bunch of images that come from traffic cameras. All right, you can see that this is an image of some sort of road with a truck on it. And I'm going to feed that into the system. I'm going to define a chat message saying what's in this image, and I'm going to attach an image content to that containing this image data. So image content is one of various content types that are defined within Microsoft.Extensions.AI. And so I can pass that in there, and then I'll get and display a response based on that. All right, so all being well, when I run that, it will pass that image to the language model backend and ask what's in it. And it says the image shows a view of a wide empty highway, blah, blah, blah. It gives me all sorts of information about the image. All right, that's good. But I don't want to just look at a single image. The business scenario I want to do here is some sort of live traffic monitoring system. So it's going to look at all the different images that you can get, maybe from hundreds of different cameras around the country or around your business, your building, whatever you want, and produce a report about all of them. So what I'm going to do is I'm going to have a little loop that goes through all the files in that directory. And for each one of them, I'm going to ask for a description. I'm going to say, extract information from the image in this camera. And then I'm going to get back that message and I'll display it. Well, if I was to run that now, you can predict what's going to happen, right? It's going to loop around, and for each one of those images, it's going to say, this is a picture of a road. Here is a roadway. The image shows a road, things like that, which is not very useful. What I want is some sort of structured information coming back. And as a .NET developer, or working with C# in this case, ideally, I want a C# object like this, traffic cam result, which has got a status on it, which is one of these values, and some other structured information that I could do something programmatic with. So one of the nice things that we've got with these APIs, as well as just getting back arbitrary text responses, we can also get back structured output. So in this case, I say, give me back a traffic cam result, and that will constrain the model to respond in the form of that object. All right, now here I'm going to check, does the response actually conform to that schema? If it does, I want to display it like this. Okay, so let's try running it, and we'll see if we get some structured output coming back. And we do. You can see for the first camera, it says that it's flowing. The next one, the road is blocked. The third one, it says it's congested. And the last one, it's clear. So let's check if this is true, shall we? Let's take this one, for example. Image 2294, is it actually congested? Let's have a look. The answer is, yeah, I guess it is. At least on one side of the road, it is congested. All right, so that seems pretty good, right? You might think at this stage, awesome, we've finished. We've implemented it, ship it, we can go home. And that's almost true, but there's one slight drawback to doing structured output like this, which is that we've constrained the model so aggressively to respond in this form that it will do even if it doesn't make sense for the image. So imagine if one of the cameras was defective and it was just producing a blank image, it would still produce a traffic cam result. Or if we feed into it a picture of a sandwich and we ask for a traffic cam result, what's it going to do? It's going to say, well, this sandwich is, I don't know, congested, and it contains no cars or trucks, probably. And your code will just get back that object and behave as if that's a sensible output because you don't know any better. So what I want to do now is a bit of anomaly detection. I'm going to raise alerts if there appear to be something wrong with the camera image. And I can do that using the techniques that you've already seen before, such as function calling. So I'm going to define another function here called raise alert. And that's just going to log stuff to the console. Of course, you could actually send a message to someone to dispatch a road crew or whatever. But we'll just log to the console right now. And I'm making that available in my chat options here, which I'm going to pass in. Now, we also need to update our prompt to tell it when to raise an alert. Because if we don't tell it, how does it know when to do an alert? Maybe it does an alert just because it's raining, or maybe just because there's an unrecognized type of car or something. So I'm going to tell it that I want it to raise an alert only if the camera is broken or if there's anything really unusual in the image. All right, let's see if that works now. So I'm running again, and we're going to go through all those images. For the first one, I see it hasn't raised an alert. For the second one, it does. It says it thinks the camera's broken. And for the third one, there's nothing. And for the last one, it thinks there's some unusual presence in the image. Let's see if this is right. So for camera 2293, is there actually something defective about the camera? And the answer is, yeah, okay, so that camera is broken, and it's quite good that we found out because we can send a road crew to deal with it. And for the last one, it says there's an unusual thing in the image. Is there? Oh yeah, okay, yes. I mean, that's moderately unusual, I suppose. We do get those from time to time, but it's good to have an alert about that as well. Okay, so there we go. That is a pretty wide range of things that we can do using these APIs that are available in preview now. I want to give you a quick overview of how this looks architecturally, and I'll tell you a bit more about how you can get started before we go to some Q&A. So, architecturally speaking, the way it works, we've got this lowest level package called Microsoft.Extensions.AI abstractions, and that just contains the core types such as the interface IAT Client and the content types. And the idea is if you're creating an implementation of a package that provides an AI service, this is what you would reference. It's just a bunch of abstractions. It's a very lightweight thing to take a dependency on. And of course, all the different concrete types of implementation of that do make a reference to that. I'll give you a list of some of those in a minute. All right, now there's also a package called Microsoft.Extensions.AI, and that deals with a slightly higher level concern, which is dependency injection and the ability to register these services in your DI container. So that obviously references the abstractions. And the intention is that a typical application would reference all of these things. So your application will reference Microsoft.Extensions.AI to register stuff in DI. You'll also reference whichever concrete client you want to use. And you'll also reference the abstractions implicitly so that you can actually work with that programming model. Now, if you are working with Aspire, then we want to make that absolutely first class as well. So we have separate package, or at least one separate package, that provides the ability to register these things with Aspire and the way that it does service discovery, so that you can register that inside your app host project and make that available in your applications. And then finally, this is perhaps the less obvious one, but there are also NuGet packages that deal with AI services as a consumer. So maybe things that implement an evaluation system or a testing system. These consume AI services. And if you want to use one of those, you would reference that from your application, and they would in turn reference the abstractions so that they can work with whatever concrete implementation the application is using. Okay, so that's the overall architectural picture. In terms of what backend implementations we've got support for today, well, we've got quite a few already. The community has responded really well. We only just put these preview packages out a few weeks ago, and almost immediately we've got a whole load of different implementations of them for different AI services that you can use. So thanks very much to the community members who've already been shipping packages that work with that. And then, of course, there's also semantic kernel. Now, I haven't mentioned it up until this point, and if you've been doing AI development with .NET, you'd probably be thinking all the way through, hang on a minute, how does this relate to semantic kernel? Does this replace semantic kernel? Like, what's going on? And the answer is, this does not replace semantic kernel, it works with it. And in fact, the entire work that we've done on Microsoft.Extensions.AI has been a collaboration between the .NET team and the semantic kernel team. So we're working together to extract these low-level APIs from semantic kernel and make them available as Microsoft.Extensions.AI. So this is stuff graduating out of semantic kernel into the core platform. And the intention is if you just want to use the low-level services like Chat Client and Embedding Generator, you can just use those directly. You don't need anything else. But if you want to use the higher level, more opinionated approaches to AI that semantic kernel offers, then you will use semantic kernel, and that will also work with the same underlying programming model. And if you're using semantic kernel, that also contains a whole bunch of other connectors that give you iChat client implementations and Embedding Generator implementations for different services, including Amazon's Bedrock, Google Gemini, all kinds of other things. So you can use that. All right, so that is all I'm going to have time to talk to you about today. I would love it if you would go and get started with this. We really want your feedback about it. If you're an application developer, then the call to action for you is to make use of iChat Client and Embedding Generator to add some AI features to your application. And if you're a package author, such as someone who provides a package for gaining access to an AI service, then we want you to ship an implementation of these interfaces as well. And if you want to read more about it, go to the URL that you see at the bottom of the screen there, and that's going to give you a whole blog post with loads more information that you can use to get started. So that is all from me.